Summary of LangChain community vector stores neo4jvector check if not null. None. Detailed definition of the LangChain community vector stores neo4jvector check if not null. This component represents a specific implementation within the LangChain ecosystem focused on managing vector embeddings using neo4j's graph database. It combines the capabilities of vector embedding storage with the power of neo4j's graph database to enable efficient retrieval and analysis of textual data. Components. Component 1. This component is responsible for storing and retrieving embeddings for text data. This component, typically a vector store, acts as an intermediary between the LangChain application and the neo4j database. It handles the translation of text data into numerical embeddings and vice versa, ensuring seamless communication with the database. For example, a user query will be converted into an embedding by this component before being sent to neo4j for similarity search. The results retrieved from neo4j will then be translated back into human-readable text by this component. Component 2. This component is responsible for managing the neo4j database, which stores the embeddings and their associated metadata. This component handles all interactions with the neo4j database, including storing and retrieving vector embeddings and their associated metadata. It leverages neo4j's graph capabilities to create a network of relationships between embeddings, reflecting the semantic relationships between the underlying text data. This allows for more sophisticated search and retrieval operations beyond simple keyword matching. Description of the architecture supporting the LangChain community vector stores neo4jvector check if not null. This component utilizes neo4j to store and retrieve text embeddings. The architecture involves a vector store component, a neo4j database, and a layer of communication that enables the seamless exchange of data between them. This architecture allows for flexible integration with various LangChain components and empowers developers to build complex search and retrieval applications. Explanation of the LangChain community vector stores neo4jvector check if not null role in PE system. This component is a crucial part of the LangChain ecosystem, enabling efficient and scalable text retrieval and search. This component significantly enhances the capabilities of LangChain by providing a specialized mechanism for managing vector embeddings using the powerful neo4j graph database. This allows LangChain applications to perform sophisticated semantic search and retrieval operations, making it possible to handle large datasets of text data efficiently and retrieve relevant information with high accuracy. Allows for efficient and scalable storage and retrieval of text embeddings using neo4j's graph database capabilities. This component leverages neo4j's advanced graph database features, enabling efficient storage and retrieval of large volumes of vector embeddings. This scalability is crucial for handling complex datasets and performing real-time searches. For example, a news organization could use this component to store and retrieve embeddings for millions of articles, enabling users to perform semantic searches and retrieve relevant articles based on their content. Offers flexibility and customization in defining relationships between embeddings based on their content and similarity. Neo4j's graph database allows for flexible and customizable relationships between embeddings, reflecting the semantic relationships between the underlying text data. This enables more sophisticated search queries and retrieval of data based on complex criteria. For instance, a research team could use this component to store and analyze a corpus of scientific articles, defining relationships between articles based on their citations, shared keywords, or other relevant factors. Efficiently handling large datasets of embeddings can be challenging, requiring optimization of indexing and query strategies. Managing large datasets of embeddings within a neo4j database can be complex, requiring careful planning and optimization of indexing and query strategies to ensure efficient performance. This includes choosing appropriate index structures, optimizing queries, and potentially implementing techniques like data partitioning to handle large datasets. Maintaining data consistency and integrity across multiple nodes in a distributed neo4j deployment can be complex. Deploying neo4j in a distributed environment can introduce challenges in maintaining data consistency and integrity across multiple nodes. This requires careful planning and implementation of mechanisms for data replication, synchronization, and conflict resolution to ensure a reliable and consistent data store.